Hello everyone. In this video, we are going to understand the structure of the periodic table as per the electronic configuration of an atom. In our previous video, we have understood the order of filling of electrons into various orbitals as per this simple technique, and we have noted down the order in a particular manner as represented inside this square box. We know the first electron will go to 1s, and after the 1s has been completely filled, the next electron will go to 2s and then 2p and so on. Okay, we have also mentioned or noted at that point of time that this distribution will help us to understand the structure of periodic table. So let us go ahead, and in this video we are going to see how this representation will help us to understand that particular structure. Let us move ahead, and we have noted down the order in which the electrons are filled once again here for our reference that we will use in the slide. We have also noted down the number of electrons that can be filled in each of these subshells. Okay, so now if we start to arrange elements in the periodic table, the elements are arranged in order of their increasing atomic number. So first of all, if we consider the lightest element, that is hydrogen, which has just one electron in its atom, the electronic configuration for this atom will be 1s1. Now by using this electronic configuration, we would like to create a space for this atom in the periodic table. Alright, and so the filling of electrons in an atom begins from 1s subshell, that is the s subshell of K shell in any atom. Okay, so the first position is created for the hydrogen atom by filling of the electron into 1s subshell, that is 1s1, and we can fill an additional electron in this subshell. So we will move forward to the next element, that is helium, which has 2 electron, and the electronic configuration will be 1s2. So by using this, we will create another position for this element in our periodic table as like this. And now after completion of filling of 1s subshell, we will move to the next subshell in the order, that is 2s. So we will start filling the electron into 2s subshell as 2s1 here, and then we can also fill 2s2. So there will be place for next two elements right here. Alright, and now the 2s subshell has been completely filled. We will move ahead and start filling of 2p subshell. Now we know that in p subshell we can fill 6 electron, so there will be 6 places corresponding to 2p subshell, that is 2p1, 2, 3, 4, 5 and finally 6 here. So we have created this many places just based on the electronic configuration for various elements. Now we will move ahead and start filling the 3s subshell, that is 3s1, 3s2, and once again after the filling of 3s subshell we will move to 3p subshell, and we will finish the filling of 3p subshell once we have completely filled it, that is 3p6 right here. Alright, and similarly again the filling of 4s subshell will begin, and now before filling the 4p subshell, we will see that in the order of energy level 3D comes before 4p, so we will start filling of 3D subshell, that is 3D1, right from here, and this will continue till we have completely filled the 3D subshell. And we know that D subshell can contain maximum of 10 electrons, so we will be filling the electrons up to 3D10. Okay, and then the filling of 4p orbital will begin just like this. 4p1 right here to 6 up to this 4p1 to 4p6. So as we are moving ahead, we are creating blocks for the elements, actually places for these elements, and we are getting the structure of periodic table. Now the filling of 5s subshell will begin, 5s1, 5s2, and then filling of 4d subshell, 4d1 to 4d10, and after that filling of 5p subshell will take place for 5p1 to 6. And now we will move ahead and start filling the sixth row, that is 6s1, 6s2, and now we will again check that the next subshell in the order of increasing energy level is 4f. So here the filling of F subshell begins and it will continue up to 4F14, because the F orbital can hold up to 14 electrons, as we saw in our previous video. And after the completion of filling of 4f orbital, we will start filling of 5d orbital up to 5d10, and we will follow the same procedure and will complete the filling of 6p orbital right here. Alright, and finally we will complete the 7th row just in the same manner as we have done for all the previous rows, and this will give us the complete structure of periodic table. Okay, and now we can divide this periodic table into 4 blocks. Actually, the elements in which the last electron goes into the s subshell are said to be belonging to the s block of the periodic table. Similarly, those in which the last electron is filled into p subshell belongs to p block of the periodic table, then D block of the periodic table, and finally we have F block in the periodic table. In this manner, all the blocks have got their name in the periodic table depending upon on which subshell the last electron is being filled. Alright, and finally So we have just seen that there are 7 rows in the periodic table, and these rows are basically called the period of the periodic table. Similarly, all these columns right here, if we count, there will be a total of 18 columns, and these columns are called groups in the periodic table. Alright, so the horizontal rows are called periods and the vertical columns are called groups in the periodic table. For the sake of the convenience, the F block is written below in this manner just to make the periodic table concise. Alright, and based on our discussion, we can conclude that the first period of the periodic table will contain 2 elements. This is because in the first period of the periodic table, we have completed the filling of only one S subshell. And since a S subshell can contain 2 electrons, we will be making 2 spaces, one S1 and one S2. Similarly, the second period will contain 8 elements. This is because we are filling S subshell, S1, 2 and followed by P subshell, that is P1 to 6, making a total of 8 blocks, 8 boxes for the elements in this row. And in the same manner, the third period will contain 8 elements, and I am sure you can go ahead and calculate by yourself the number of elements in each period of the periodic table. Okay, so in this manner we have concluded the discussion of a structure of periodic table based on the electronic configuration of an atom. Thank you so much for watching. Let us meet in our next video, in which we will be exploring the modern periodic table in more detail. We will see the application of electronic configuration in somewhat more detail. Okay, so thank you once again. See you in the next video.